Hi, this is Josh Joseph, Aiden Horvitz, and Max Lee presenting our playlist app, Jams Playlist.
So the project had several goals. The first of which was that we would initialize our application by reading in a database of playlists and their songs. So what we're going to do, we're going to start off by loading up our application.
Here it is.
And by default, our application loads in the initial
day0.txt file. What you see here on the screen is the top 8 most popular playlists. So from this text file, we've got a whole list of playlists represented by integer values for songs and an associated popularity. We load those entries into a binary search tree, and from that structure, we're able to quickly retrieve the top 8 most popular playlists and present them here on this screen.
Now, another functionality of our GUI is the ability to perform autocomplete, string completion. So, for example, if we were to type in the words hello, we can see that these are the songs in our song list. And if we wanted to, say, demonstrate the most popular playlist associated with the song Hello World, we simply choose the song Hello World, and here, listed below, is all the songs in the playlist that Hello World song is listed in.
What's happening in the back end here is, firstly, for the string completion, every single song title that is in our database is first entered into a trie data structure, and when a partial string is entered, which is a valid entry that matches a node in the trie, we then perform a recursive traversal from that starting point and retrieve all of the songs that have the matching prefix that was searched with this search bar. The next step is to retrieve the popularities for those individual songs that matched the string and show only the top 4 most popular songs. And that's what you see in the auto-completed entries here.
So we have a separate GUI page here where you can create a playlist. So you can add songs at will. So go right ahead, add some cool music. Okay. I don't know, how about some classics maybe?
Some classics, okay. Like what?
I don't know. How about, yeah, why not? How about some really cool stuff like, oh, that's not in the playlist.
What a shame.
Okay.
They should really add that, Josh. You're missing out.
Sure. Okay.
Yes.
I think we have a pretty good playlist. We could rock out to this, but how popular do we want to make a playlist?
No, that's a good question. Let's make it popularity 100.
100. All right, let's give it a whirl. Let's see if that did anything to our playlists. Hey, look at that.
So what you see here is that the first entry in our top 8 has now been replaced by the new playlist we created. It just so happens that until we put that playlist in, none of the playlists in the app had popularity as high as 100. And we can see that all the loose ends were tied up and individual song popularities were updated when we, for example, search for one of the songs in the playlist. So that new playlist, let's try to find all the small things. And if this works, we should display the new most popular playlist that includes this song. And as you can see here, these are the 4 songs we added on the other page. Here that every access point for looking at the popularity of songs and playlists are all updating one another when we update the database.
Hey, Dean, what was the reason for using a binary search tree? Not once, but actually twice in our implementation.
Well, there is a large binary search tree that holds all of the playlists And that allows us to do this coarse-grained retrieval on this first page, where we just see what are the top 8 overall playlists. And in order to actually present what's on the right half of this screen, i.e. the most popular playlist that includes a specific song, we also actually have to have a mini playlist, a mini binary search tree for every song in our database. And what that means is every time we add a new playlist, we not only add it to the large binary search tree, but we also have to add it to every mini binary search tree for the individual songs in that playlist. And that allows us to look at a specific subset of playlists that have a specific song on it.
In one of the exercises, we used a min-max heap. Since you're often trying to figure out what the maximum popularity playlist is and the minimum popularity playlist, why didn't we use that data structure?
That's an excellent question, Josh. The reason that we decided to go with a binary search tree instead of a min-max heap is largely because we need to be able to retrieve the top 8 most popular playlists, which is certainly possible with a min-max heap. However, it's much more straightforward with our, actually it's a modified binary search tree, which in constant time finds the maximum popularity playlist and then simply finds the successor 7 times in a row, which runs in big O of log n time. The min-max heap also has the benefit of giving us access to the most popular and least popular playlists. However, this was the most straightforward way to access consecutive playlists in this popularity ranking.
Max, you spent a lot of time working on the UI. Was there anything in particular that you learned that was kind of like new programming skills in doing that?
Yes, Josh. Thank you for the question. I did. I learned quite a lot. So our UI was actually created using the JavaFX API. And I learned actually how to do event-driven programming. So, like in the case of our search bar, every key press like that is actually an event that would call out to our backend functions and do a particular thing to present in our UI front end.
Very cool, Max.
Thank you, Aiden. I appreciate it.
We've got one more demonstration of an added function that the playlist app requires, which is to upload in bulk a text file of new playlists.
So here, for demonstration convenience, we have made an upload list.txt with song names and the playlist popularity. Now, what we're going to do is we're going to upload this text file here, upload it, and as you can see, our top 8 playlists got updated. So
here, let's open that text file one more time so
sure.
we can compare the two. You can see for our most popular playlists, 102, if you recall, the first playlist we entered had a popularity of 100 and was the most popular. Song number 3 is simply repeated over and over again, and we put it in twice, and that's just to make it a little more obvious what we're talking about. And you can see Hot Toddy must be song number 3, and it's repeated there over and over in that list that shows up twice. Similarly, with 101 popularity, we've got this song list number 3 and 4 with Get Back Up repeated repeatedly. Well, it's a great combination of words there. And you can also see that the first playlist we entered, All the Small Things here, remained at 5th place even though we entered 2 new playlists with a popularity of 100, and that's more or less an arbitrary choice to allow earlier playlists an advantage if there are 2 playlists of the same popularity. So Aston Martin here, Aston Martin Music, this song is actually tied in popularity with the first playlist that we entered right here. And this process of uploading from a text file is a functionality that occurs upon initialization. When we just launch the program, we load from a text file that has over 1,000 playlists, and that's the current state of our database. And on our second page, by being able to upload while the application is running, we can update our database with a new file of more current playlists. Thanks for watching, everyone.